Okay, everybody, so in this video, we're just going to simplify this rational expression. And it's a sum of two rationals, so what I'm going to need here is a common denominator. But before I get to that, I'm going to need to do some factoring. Now, the numerator of the first term really can't be factored down nicely, but the denominator can be broken up. Now, 3 as that leading coefficient there, that's kind of nice because that means my first two terms here have to be 3x and an x. And then 8 can be broken down into 2 and 4, 4 and 2. So let's try 2 and 4. See what happens here. Now, if I multiply 3 times 4, I get 12, and I get a 2 there. And whoa, I can't make those two numbers differ by 2. Whoops. So what I got to do is just switch my guess. And that's typically how I'm approaching this. I'm just going to do guess and check. Whoops, sorry, I don't know why I put an X there. 2. Now, 3 times 2 is 6. 4 times 1 is 4. And yes, I can make 6 and 4 differ by that 2, as long as I make that negative 2, so it'll become negative 6 plus 4. And then I check 4 times negative 2. Does that give me negative 8? Yes, it does. Good. So I feel good about the factoring there. This next one here, same thing. I'm just going to guess my two binomials here. Again, that 3x squared breaks down into 3x and x. That's the only way that that can work because it's a prime. And 4, now I'm guessing that this is going to be 2 and 2. It might not be, though. Okay, it might not be. It could be 3x and 4 and 1 here. But let's just take a look at this. 3 times 2 is 6. 2 times 1 is 2. Well, 6 and 2 can't be made to come together and differ by 1 there. So it looks like maybe that was the wrong thing to guess here. And now let's try that 4 and 1. And that's actually a pretty good guess because there's a 3x plus 4 over here. So I'm assuming that this is also going to be 3x plus 4. And then to make that a minus 4 down there, this has to be a minus 1. Now let's just double check. 3 times 1 is going to be negative 3. 4 times 1 is 4. And negative 3 plus 4 is, in fact, that positive x that I'm looking for. Good. So now I'm ready to add these two fractions together. Now, in my common denominator, in my denominator here, I need a factor of 3x plus 4. Okay, so 3x plus 4. In my first term here, I've got this x minus 2, but what I'm missing, the one that's present in the second term, is this x minus 1. So I've got to put an x minus 1 here, and if I put it in the denominator, I have to put it in the numerator. And then over here, I've got this 3x plus 4, and I've got my x minus 1. But the factor that I'm missing over here is x minus 2. So I need to put an x minus 2 here, and then put an x minus 2 in my numerator. Now, my denominators are the same. I've got 3x plus 4, x minus 2, x minus 1. Now, up in the numerator, I have to expand these guys out here. So this is going to be 9 times x is going to be 9x squared, minus 9 plus 2 is going to be minus 7x minus 2, plus, and now I'm going to distribute the 7 by the x minus 2 and get 7x minus 14. Good. I'm not going to do much quite yet with that denominator. We'll see what happens here. But in the numerator, I'm going to simplify that down. There is no other term that's got a square in it, so that's okay. I'll leave it like that. But I've got a negative 7x and a positive 7x. That cancels. That's awesome. And then I've got a negative 2 and a negative 14, so negative 16. And that, interestingly enough, is a difference of squares, which means I can factor that down as 3x minus 4, 3x plus 4. Wonderful. And now the 3x plus 4 terms are both common, so I can cancel that out, and I'm going to be left with 3x minus 4 over x minus 2, x minus 1. Now, I lost a factor from the denominator, so I really have to point out that I lost an obvious non-permissible value, and that was where 3x plus 4 went to 0. So that's a negative 4 thirds that I no longer can see in my final answer. So I really have to state that. And then there's going to be a little bit of push on all of you to indicate all the other non-permissibles as well, which would be positive 2 and positive 1 as well. You're not usually expected to expand out the denominator because it makes it harder to see those non-permissibles.